So for this customer, we found a Jenkins server on the internet. It was protected by authentication. In fact, it was integrated with Active Directory on the back end, but it had no MFA enabled on it. We went to LinkedIn, and the company was fairly large. We found about 250 employees that worked at LinkedIn for this company. We went to hunter.io, and we also gathered email addresses for employees working at this company. Now, the email address itself wasn't important. What we were getting from hunter.io was the format of the email. So from the format, we were able to tell, hey, a typical username at this company starts with the first initial and a last name. So we combined that with all the employee names we got off of LinkedIn, and we generated a list of about 250 probable usernames. Then we generated a very short list, about 3 passwords that we thought were likely to hit on. And this was just based off of the company name. Think about your own company name. Users are going to use passwords that they can remember and are going to get by the default, whatever password policy you've set up. So it's going to be something like, there's a good chance there's some user in your company that's got a password like your company 1234 or your company 1 exclamation mark. Whatever your password policy is, however long it is, let's say it's 8 characters, they're going to pad it out to that amount, make sure they have whatever special characters they need, and it'll look fine from a security perspective, like it'll meet your password policy, but it's actually not secure. Obviously, attackers know this. So we generated 3 passwords, and we kept the list short because we didn't want to risk locking out any accounts. And then we just did something dumb. We just brute forced it. So we took all the usernames and the short list of passwords and tried all the combinations. Just based on that, we found that we could authenticate 20 employees into this Jenkins server. Now, of those 20, a lot of them could authenticate, but they had no rights inside of Jenkins. They weren't actually, developers within the company. But a couple of them were legitimate developers. They had privileges inside of Jenkins. They were not admins inside of Jenkins, so they were regular users, but they were still users in Jenkins. And if you're a regular user in Jenkins, you actually get access to quite a bit of information. So you can see all the builds and build logs, and then you can start, if people don't set up their build jobs in a secure way, often they leak tokens and so forth. So for this particular company, just using regular user access, we were able to get access to their Elastic Container Registry hosted in AWS. And then we could pull and push images and so forth. The next step for us was we wanted to escalate from a regular Jenkins user up to a Jenkins admin, because a Jenkins admin can do a lot more. Jenkins and a lot of web applications have features where you can see all the users in the system. So Jenkins has a feature called People. It's a page you can go to, and it'll just give you a list of all users inside of Jenkins. So we didn't have to guess anymore. So it was at our disposal. We didn't have to go to LinkedIn. We have a full list of users inside of Jenkins. So we took that list and we just repeated the password spray again. We had a better list because we knew it was coming from inside of Jenkins. We didn't password spray the same users again that we did before. We kind of took the delta and we tried again with the new set of users. And this time we hit on another account that happened to be a Jenkins admin. Basically, starting with open source intelligence, we're able to get Jenkins admins access. So what can a Jenkins admin do? It's actually kind of a disaster from a security perspective. So first, we have access to credentials inside of Jenkins, which have to be stored in plain text in some format for Jenkins to do its job. Second, Jenkins has a feature called the script console. It's really handy for debugging as well as attacking. So what it essentially lets you do is run code on the Jenkins server, and it's whatever code you want to run. So it's equivalent to remote code execution. So any command you want to run on the host running Jenkins, you can run through the script console. One of the most attractive targets for attackers hitting cloud infrastructure, and so this particular case, it was a Jenkins server running on a Kubernetes node hosted in AWS. One of the most attractive targets, as Zach described earlier, is something called these metadata URLs. So all or most hosts inside of AWS or Google Cloud or Azure, they have these magic URLs that you can hit that are only accessible inside the host. But if you're able to hit them, you can get the credentials that host is using. And those credentials define the role and privileges and permissions that host has for the types of things it needs to do. So for AWS, there's a well-known URL you can hit. And through the script console access, we're able to just curl that URL and dump out the access key for that Kubernetes node that was running Jenkins. So that combined with the other credentials that were already in Jenkins, which also included other AWS access keys, we're able to compromise a significant part of their AWS infrastructure. So we enumerated permissions. We had access to their production EC2 instances, S3 buckets, RDS, and so forth. So we had access to AWS. We also found from that Kubernetes node, because the networks weren't properly segmented, we could access their internal infrastructure. It's very common to have an on-prem network that is connected to your AWS or cloud network. And so we found from Kubernetes node, we were able to hit the Windows domain controllers on the internal network. And so you can kind of guess what happens next. So as Zach mentioned, if you all these users we had from Jenkins, they were all domain users because it was authenticating using Active Directory. From Active Directory, we were able to dump out all the users in the system. And because Active Directory will tell you all the privileges and groups of different users, we were able to identify who the domain admins were. And so to complete it, we did another password spray, starting with the same 3 original passwords we had in the beginning. And one of them happened to be kind of a throwaway domain admin account that someone forgot and left behind. And so then we had domain admin privileges on the entire internal network as well.